specifically looking for, oh, did you make a relative frequency like they told you? Like, did you make it by the row or by the column? And they tell you in each one. So just very carefully make sure you're reading through and looking at those, okay? So finding the relative frequency, this one says by the row and the column. So when I look at number 7, I should see one, thank you, that you made it by the row, and you did relative frequency that way, and then I should see another one that you did, and you made it by the column. So you do need these totals when you're looking at those. That's going to be very helpful if you didn't do those today, to get that marginal data. So make sure that you fill all of that in and you have all of E1 done. We are looking at E2 right now. So in your notes, E2. And in E2, if we look at the I can statements, and the I can statements is kind of where we're getting our information for what's going to be on your test as we look at it. So I can construct a dot plot and a histogram for a set of data. I can choose the best type of graph for a set of data, decide if the representation preserves the data values or presents only a general characteristic. So when we do our histograms, histograms only present general characteristics. They do not give us exact data values, whereas stem and leaf and the dot plots give us very specific information, and then choosing the appropriate one to represent our number line. So this is for the hours spent sleeping per night. They surveyed some people. How many people did they survey? Can you tell? How many people did they survey in this? How could we determine? Do what, Owen? Count the dots. So count the dots. Count how many we have. They surveyed, in this case, how many people? 16 people. Okay? Dot plot is a type of graphic display that's used to compare frequencies or counts within categories or groups. Or it could be using a number line. The dots are stacked in a column so that the height is represented in our frequency. So, going back to some other statistic words. The word mode. Anyone remember what mode means, Joey?
The sum of
Nope. Not a sum.
everything
Mean is the average. Okay. Mode is the number that occurs the most. Okay. Which in our case would be what? 6.5. So the one that occurs the most, in our case, the mode would have been 6.5. The range, we usually want that as a single number. So how do we get it as a single number? Anyone remember what the range is? It's when you take the maximum, the largest one, minus our minimum. So the largest number, maximum minus the minimum. So in our case, our maximum is 9, our minimum is 5, and we would say that our range is 4. That's just telling us from our top number to our from the bottom number to the top, there is 4 like units there. It's not saying that we can't have these decimal ones that people had, how much they slept. So we have mean, mode, range. There is another statistic word that we will be using coming up. It is the median. We're not using the mean and the median too much today. That's why I didn't have those ones up there. But anyone remember what the median is, Anna?
Like the number in between.
Kind of in between, and we actually call it our middle. And if you've started your driving, since most of you are in that getting your permit, the middle, the median is what goes down the middle between the 2 roads. It's the middle of our data points, right? So in this case, it's the middle number, the middle data point. Sometimes it will be halfway in between, meaning if halfway is between 6.5 and 7, you could have the median being 6.75. It doesn't necessarily have to be a data point. Neither does the mean, the average does not have to be one of our data points. Whereas the mode must be a data point. It's saying which one occurred the most often, okay? So, some vocabulary. You are now asked, and I just want you to be aware that these numbers are off. So like when we printed it, the numbers got off. So please put the right numbers. So this would have been 4, right? This would be 5. And you're going to make a dot plot right now. So when you make your dot plot, my hint would be not to cross this off and make it dark. But at 7, you're going to put a dot, right? Then you're going to go to 17. But you need to write the right numbers down below. So 9, 10, 11, 12. And you are simply, they just didn't, like the fonts when we printed it, they kind of change fonts sometimes for some of these when you change them to a PDF. So I have 17, I'm going to put a dot, so please make yours now if you have not. From this data, the number of home runs that our batters in the local home run derby are listed. So we had 7, 17, we're going to have 14, we're going to have 2, okay? The other 2 things I want you to tell me is I want you to tell me what is your range of your data and what is the mode. Okay, what is the range and what is the mode? So hopefully as you finished yours, it looks kind of like this. And our range of data would have been, Abby, how much? 15. Again, how did we get it? We took our largest, our maximum, minus our minimum. So 15 is our range that we're looking at. Our mode in this one, if I'm looking at it, should be auto. We're not going to look at the mean and the median. You could with this data, like you could find the median and count halfway into the middle and then find how many. Okay? We're not going to be looking at that for this first part. That comes up a little later. So then, this is our next part, is making a histogram. So if you turn to the next page in your notes, and you kind of look at making it, and then it talks about what it is. So a histogram is a graph that visually displays the distribution of data. A histogram has 1 bar for each interval of our data. The height of each bar shows the frequency of the data within the interval. So it's within that interval. There's going to be no gaps when we look at ours. There's going to be, the bars are always going to be equal width when we look at those. So they're going to be, so as you're looking at that data, that's what you need to be really kind of careful for. That there's going to be no gaps between our bars as you look at those. So again, my font changing this from last year to this year, kind of ugly. So some of these went over the top on that. So, all right, so here's our data. We're going to talk about how do you make one of these. Television data below for the number of hours per week that a group of students spent watching television. What is a histogram that represents the data? So your end goal was simply to make a histogram. They give you all of this information, okay? Notice we have a 0, and then our highest number in this case was 22. So we have our minimum of 0 and our largest number of 22. One of the first things you're going to be asked to do is choose the interval. This, for a lot of students, seems to be the hardest part. Sometimes I will tell you the interval is going to be in the hundreds. Other time I'll say the interval is going to be 2 or 3. Okay? If it's open-ended, this is sometimes where people will have different answers. So we choose the interval. We looked at going from our largest one was 22 to 0, which means we have going from 0 to 22. We need to make sure all of those are included. So we need to make sure 0 is included. I want you to put the word tally behind here. Because generally when you are going to be making a histogram, you might even actually put the tally here and then put your frequency. So if you remember in elementary school, when you surveyed people, you did these tallies. So This was just telling us that we went through this data up here, we had 6 tallies, right? We went through. This would have been telling us, if I was going through the data, I had a 7, I had the 10 was in here, all of those numbers. This was telling me that I had 3 and 1, right? So that if I go through here, I'm putting these tallies first. Usually after every 4, we put a line across to show 5 of them, right? And then we write our frequencies. The question is, how many numbers are between 0 and 5? What are we talking about? Am I talking about 5 numbers or 6? And here's what you want to think. You're counting the number 0. That's part of ours. 1, 2, 3, 4, 5. So this is actually 6. There's 6 numbers within here. People always think that, oh, 5 minus 0 is 5, so there's only 5. There are actually 6 numbers in there, right? If you include 6 and you count 6 to 11, counting 6, 7, 8, 9, 10, 11, you have another 6 numbers, okay? And the key thing, we had to go to 0, and we have to make sure that 22 is in here, right? So this had another 6 and another 6 numbers, okay? Once you've set your interval, you make the frequency table, you go through the numbers and you do the tally, you then write in the frequencies. These 2 categories are what you use to set up over here in your histogram. So once we make our histogram, labels are things that are really important. Notice no spaces between our bars. Labels down here of hours, label over here of frequency, and a title, okay? Some of you did a great job. I know on the test this week, when you get that back, I listed like what were your variables, like which one was the type of coffee. I had some people switch that around, but generally most of you were able to follow that. But on our test for this one, you will need to make sure you put the labels. So making the frequency table with the histogram, this is like probably an 8 to 10 point question, right? Because I need to see what were your intervals here, I need to see your intervals here, probably your tally and your frequency. I need the title on the graph, and I need the axis labeled appropriately. So we're going to try and make one now. So the first question as you look at your notes is, these are the finishing time in seconds for a race. What is a histogram that represents the data? First thing I want you to do is find the range. And when you find that range, show me what you're subtracting. So right up here above race times, tell me the range. Tell me your maximum minus your minimum to tell me your one number that you have for the range. Write that down first, because you need to know your intervals before you start doing anything else. We need to know what that interval is going to be. So the largest number, if I was looking, Owen, was what?
105.
105, and our smallest one was 105 to 80. So I have a range of 25, okay? And my lowest number is 80. So I definitely need 80. And I notice that I'm going 1, 2, 3, 4, 5 different, as I'm looking at that, 5 different intervals that we are looking at. And we have to include 105. So if we are looking at this one, and you try to go from 80 to 85, will that work? Don't write this thing down, but will that work? Will I be able to get 105 if I go up here? If I only have 5 numbers in each one. If I have 80, 81, 82, 83, 84, 85, right? If I go from 0 to 85, is that going to work? So what a lot of people will think sometimes is that they can actually go 84. Does 84 work? 5 numbers in here? This one would then be 85 to 89, right? 90 to, will I get up to 105? Only 104. So we need to make sure that our data goes up to 105, correct? If we are looking at that one. So you gotta be kind of careful. So we're gonna go 80 to 85. We have 6 numbers in this interval, okay? We're gonna go 86 to 91. Again, there's 6 numbers. I don't care if you do your tally in the middle here. My suggestion is I would do it back here, just this because you have a little more room. We're going to have from 92 to 97, right? You got to count 6 numbers. 98 all the way up to 103. And then we have 104 and up to 109 in this case. We're going to start 95. That would go down here. That would be my tab. 105. 105 goes here. 83. So first you make the tallies, 80, 93, and you're just going to fill those in. And then what we put on our graph is our frequencies. We have 98, we have 102, we have 99, 82, 89, 90, another 82, and 89. So if I am looking at mine, my frequency is that I had 4 in that 80 to 89. I have 3, 2, 2. Did I miss one here? Yeah, it should have been 3. And I think I put it in the wrong one. This should be 1, right? I should have 3 here and the last one. I only have that 105 in that range, okay? So then we go over here. They already have the word frequency. We have race time. So our time down here is going to be our time in seconds. Now, notice they have this broken graph. Our intervals here are 1 for our frequency, 1, 2, 3, and 4. The reason they have it broken is that our times are starting at 80. If you're going to start at 0, you need to go all the way from 0 all the way up to this 109. You can always put a broken graph, just putting that in there and showing that we are starting actually going from 80 to 85. Now sometimes when people put this, they have a hard time fitting that in. So sometimes my recommendation is that you kind of do something like this, and then you could go, oh, this is going to be 86 to 89, right? Some of you write small enough that this is going to be from 90, 86 to, it wasn't 89, it was 91, 92 to 97, so you need to list those intervals as you are doing that. 98 to 103, and then make your bars. And when you go to make your bars that you're making for your histogram, the key thing is that they need to be the same width and there's no spaces. So this first one was a 4. So we have 4. And I don't take off points if you don't get them exactly the same width, but you should try to get them the same width as you are doing these. We had 3, we had 2, we had another 3, and 1. And then, of course, some of you are already shading yours in. Sometimes you'll notice that they shade them different ways, like they'll do it this way, and then it doesn't matter to me as long as you can tell where your bars are and that they are right next to each other. And the reason that they are right next to each other is this has all the data up to 85, and then we switch to 86. So a histogram, different than a bar graph is usually with categories. Like if you ask people, what is your favorite social media, right? They're going to pick one of these, whatever it happens to be, but they're individual categories. So a bar graph, different than a histogram, would say, oh, here's one bar and here's another one, and you don't have anything in common in between here. So a histogram is where you don't have any of those spaces, okay? So then we talk about different types of histograms because you're asked to interpret them after you are doing this. And so one of the big things is with making all these different graphs is not just making them, but how to interpret it. So words that we use to describe the shape of our histograms. The first one is called a uniform histogram. It's roughly everything's about the same. All the categories came out to be exactly about the same, right? Some are a little higher, but pretty much it came out equal. The second one is symmetric. It's not exactly symmetric, but it's kind of like if you would fold it in half over this line, right? And we think of this line going down here. it kind of matches up on both sides, okay? So it's kind of like a mirror image, symmetric, okay? It doesn't have to be exact in order for it to be symmetric. This is often sometimes when we get to the next one on Thursday, we talk about central tendency. We talk about the bell-shaped curve with our statistics and where that comes from with the standard deviation and doing some stuff like that. And then this one is skewed. This one is skewed so that our higher numbers, we had more at this end, whereas this one would be skewed the other way. So this is kind of like positively skewed, this is negatively. How do you know if it's positive or negative? Because we think of our slopes, this is a positive slope, right? Whereas this is our negative slope, right? So just looking at them that way. So as we look at this one, it says here's the data that shows us the battery life in hours for different brands of batteries. So you're trying to decide what kind of battery should I buy if it's going to last in my flashlight, right? Or your radio or whatever you have. It says describe what this graph tells us about battery life. So batteries that last between 9 to 12 hours from the number that they surveyed, they had 7. Here they have, it looks like 2 that lasted from 13 to 16 hours, 1 that lasted 17 to 20, and 2 that lasted from 21 to 24 hours. If you were going to use one of these words up here, symmetric, skewed, or uniform, how could we describe this if we are looking at it? It would be one of the words. What word do you think would be best used for this one? Probably that it is what? Skewed? I would say so. So if we are looking at this, we could say, describe what the graph is telling us about battery life. It is skewed in that most batteries last how long? Most of the batteries that we surveyed lasted between 9 to 12 hours. Okay? But there were a few. There were a few batteries that lasted how long? Between 21 to 24 hours. Right? So could a company say, hey, look at this. We have batteries that last up to 24 hours, and that could be their advertisement pitch. Would that make sense? Yeah. Batteries lasted between 9 to 24 hours. Yes. Could they just say, we have batteries that last 24 hours. Most of our batteries, they can't really say most, right? But they do have batteries that lasted up to 24 hours, right? So depending on whereas maybe a consumer watch group might be going, yes, you do have a few that give you 21 to 24 hours, but you know what? The majority of yours last between 9 to 12 hours. So data can be used many different ways to present many different pictures. Kind of depends on what you want people to see or believe. Okay? So that next one is talking about stem and leaf plots. You guys have made stem and leaf plots before. Last class was like, yep, we've done these. So when we look at our stem and leaves, the key thing is that when we are looking at it, it shows all of our values. So you can make the frequency distribution in a histogram. That's a summary of values. So a histogram kind of combines them into groups, right? We do not know in this histogram if these were 10 or 19s or if there was how many, right? We don't know if it was 15 and 15. We don't know if it's exactly in the middle. We just know there is 2 numbers that were between 10 and 20, 2 between 20 and 30. So a histogram summarizes, whereas the stem and leaf plot is going to show each individual value. Whereas here, we have 12 and 13. So one of the first things you always need is your key. In this key, it's telling us that the 3 is in the tens place, right? And this 3 is in our ones. And the question that I was asked last period was when we were doing this, do we need to put these in order? Can I put 3 and then 2? Yeah, you want to go from the smallest to the largest when you look at your numbers. So as you're going through and you're putting them down, you might at first have encountered like the 37 first, in ours it's last, but you would then rewrite it and put the 3, 4, 5, and 7, because it's telling us 33, 34, 35, and 37, right? So when you look at this 40s, here we can't tell what the values were, but here we can tell we had 2 40s and a 41. So there's not many that are going up to 50 in this class if we're looking at that frequency, okay? So it says, what's the benefit of seeing the data values rather than just a summary like the histogram? So what do you think would be the benefit if we were looking at that? What do you think is our benefit of seeing this rather than this one? I don't see any benefit. Yeah, looking at it. The stem and leaf tells us what? The stem and leaf tells us our exact, or all of our data points, right? That might be very important if we're trying to talk about something, because there's really nothing past 41 here if we're looking at this list of values of showing something. And the histogram, it's just a summary. It summarizes things, okay? So histograms are good for like big picture and showing someone something, but stem and leaf gives you more individual data points. And it all depends on who your audience is or what you're presenting. So you are asked right now to make a stem and leaf plot. When you do that, one of the first things you probably need to make sure is what's your range. You need to know your max minus your minimum, because you don't necessarily want to start down at 10 or 20 even. The other thing you need is you need a key. So you need to be able to tell me the two numbers on one side of your stem and then your leaf, and what does that equal? So if you were looking at this data, what would you say our stem is going to be? Looking at our numbers from 73, 42, 67, Ryan, what would you say our stem would be? What place value would you go with?
I don't know.
You don't know. Could you give me an example of, like, if I wanted to show that this equaled 73, how you would write that? The stem would be the what?
Like, yeah, 7.
The stem would be the 7, and the leaf would be the 3 to show 73. So you want to put your key so that everyone knows, oh, this is how you're getting it, right? Then, our smallest one, Becca, was what number?
42.
42. Which means when I'm looking at my minimum of 42 and my maximum, Samantha, what do we have? 99. So we can find that range. That means I need to go from the 40s up to the 90s. You cannot skip the 50s. Someone said, yeah, but there isn't a 50. That's fine. You don't get to skip it. So you want to make sure you have your lowest one, because we had a 42. Should I put something in for the 50? Should I put a 0? No, you can't put anything here, right? You want to leave it blank, okay? The reason you want to leave it blank is that if you put the 5 with a 0, that means 50, and we did not have a 50, okay? We had no 50 in our data. So please fill in the rest of yours. As you are filling yours in, I'm going to pass out your tests, and then we'll do wildcats. And we did have a couple of 100%. So nice job. All right. So just as we were filling in the rest of this, I should have had a 67. I should have had 73 and 78. I should have had 82, 4, and 6. And I should have had 91, 4, and 9. And the nice thing about putting them like this is if you kind of turn this on its side, you actually almost have a histogram, right? This would be your 40s. 50s would be 0. This would be my 60s at 1, right? This would be my 70s up to 2, my 80s go up to 3, and my 90s. So if you turn it on its side, you actually have a histogram if you are looking at that, right? So if we would just turn this, if I had that tool and I could just take and turn this, you would have a really nice histogram. It's just that now it gives you the values of these, okay? So, as you know, you should have both E1 and E2 done. In the E2 homework, questions 4 and 5 and 6, they tell you what to use for the interval. So, when I am looking at the number of pages, you're asked to make a histogram. So, I don't know, I think yours might have enough room here, but you're going to put the page numbers, and what's the smallest number of pages we are talking about? If you look at number 3. Whereas here they're telling us to go with intervals of 2, right? So I kind of underline those. That tells you how many numbers you want in there. So if I'm going using an interval of 100, my smallest one is at 300, 311, I think. So we're going to go from 300 to 399, right? Then we're going to go to 400 to 499. Then over here, you're probably making your histogram with labels and putting your, so you have to make the table first in order to make the histogram, okay? So when I'm looking at yours, I need to see not just the histogram for an answer, I need to see this part first and then how you got that. When you look at, there's only the 2 pages, so you go through question, I think it is 11. Number 6 and 7 ask you to make a histogram first with an interval of 2 for this data, and then it is a histogram with an interval of 4. Do not cross these off. I would suggest putting a check mark after you use it. Why? Because you need to set up and make your, what was this talking about? This was talking about snow in inches, so you're going to have your inches of snow, and then you're going to have your frequency, or your tally, and then your frequency, and then you have to do the same thing before you make the other one. Okay? And you need to do another one over here with inches, with your tally, and your frequency. And then you make histograms for each one, okay? So you have to make 2 histograms, and the reason they want you to do that is they want you to think about, does it matter? What does the data show us when you have an interval of 2 versus an interval of 4, okay? So a lot of times they might give them to you. They're asking you to interpret those questions, okay?